In this video, I'm just going to explain to you how to do the practice or homework. So on these, you're going to be given a picture and you're basically going to be labeling some free body diagrams. Now, looking at the directions here, it says match the story below to the correct free body diagram. The top box above each free body diagram should be filled in with a story that matches the free body diagram. Right below that, label the free body diagram as balanced or unbalanced, then label each force with the correct label for the story. So if you see here, there's two stories and there's two free body diagrams. So one of these free body diagrams is going to match story A and one is going to match story B. So one of the things you might want to do to start is looking at these two free body diagrams. You should be able to tell which one is balanced and which one is unbalanced. So the one where the arrows are all the same length is going to be balanced. So I can go ahead and I'm going to label this one right away. This one is going to be unbalanced because our horizontal forces are not balanced. So I'm going to label this as unbalanced. Now I just need to look in the story and see what tells me which one is balanced and which is unbalanced. So Jason's car broke down and he is trying to push it out of the road. He pushes as hard as he can and the car begins to move. Remember that begins to move, those are words that indicate that it's unbalanced, that the forces are, that we're going to get a change in motion. So the one that's going to go with story A is the one that's unbalanced. So I'm going to find story A and I'm going to label this story A. Looking here, Jason's car broke down and he's trying to push it out of the road, but the wheels are stuck to the ground and the car remains at rest. Those are words that indicate the forces are balanced. So story B matches with this free body diagram, so I can go ahead and label it. Now I need to label the forces. Well, there's certain forces that are really, really easy because the weight force is the one that is always pointed straight down. That's always going to be the weight force. Now, because we have a surface and the car is sitting on the surface, the force that is pointed straight up, which is perpendicular to the surface, is going to be the normal force. And both of these are going to have the normal force. Now be careful because there are problems that do have an upward force that are not, the object is not sitting on a surface. So the upward force isn't going to be the normal force. All right, so now we also know that he is pushing to the left, and so the arrow that's pointing to the left is going to be his push or push-pull, and that's going to be true on both of them. Now what's different about these is going to be the force that's pointing in the opposite direction. And as we discussed in the previous video, when the forces are balanced, that was when it wasn't moving at all. This is when the car remains at rest. When it's at rest, that backward force that's opposing motion, that friction, is going to be the sticking friction or static friction. Whereas when it starts moving, as soon as it starts moving, it changes from static friction to kinetic friction. So that's how you do these problems. And there's another kind of problem, let me just pick one, that might look like this. So I'm not going to go through this whole problem, I just want to explain one of the twists. So this says label each free body diagram as balanced or unbalanced. Then pick the free body diagram that matches the story and label each of the forces. Put the incorrect label in place for the forces in the free body diagram that does not match the story. So the first thing is doing our balanced and unbalanced. Well, this, again, you should be very good at this by now. This one's balanced and this one's unbalanced. Now, I'm not going to actually read this story. What I'm going to say is if I read the story and I find that my forces should be unbalanced, that means my unbalanced forces are going to get labeled. My balanced forces, or the forces in my balanced free body diagram, I don't want to use that one, so I'm just going to label this as incorrect. Now again, I don't know which one of these should be the correct free body diagram, so don't take this as the answer. But this is what you were going to do for the free body diagram that you say is wrong. The reason is because the problem wouldn't let me allow you to leave anything blank, so I had to have something to put in there. I only want you to label the free body diagram that's correct. All right, and one last kind of problem. We are going to have a couple of graph problems where you need to identify whether the forces are balanced and unbalanced straight from the graph. So this is a speed or velocity versus time graph. And if you remember, the slope is acceleration. So if we have a slope, we are going to have our object changing its speed or changing its velocity. So up here, I've written, when forces on an object are balanced, the object moves at a constant velocity or remains at rest. When forces are unbalanced, the velocity of the object changes. So we're going to use the drop-down menus to indicate whether the forces in each labeled section of the velocity time graph are balanced or unbalanced. Well, this is going to be really, really simple, but you have to practice it, you have to know it. If I have a slope of any kind, my forces are unbalanced. If it's flat, that means my velocity is a constant 15 meters per second here. If my velocity is constant, my forces are balanced. Here I have another slope. It's not a constant velocity, it's a changing velocity. So again, it would be unbalanced. So I can't do the rest of it. It goes outside my frame. But that's how you do the graph questions. So that's it. If you have any questions, please ask me or Ms. Geiger.